Hi again, everybody. One more example for the first section of the gas laws. I ran out of time on the last video, so I wanted to do one more example with you on the combined gas law. So my CP Kids Technical Chemistry, this is problem number 12 on your first worksheet, and honors, this is number 20 on yours. The problem reads, the volume of a gas is 27.2 milliliters at 22.8 degrees Celsius and 0.523 atmospheres. What will the volume be at 17 degrees Celsius and 1.04 atmospheres? So just like the rest of the problems, we want to list what we know and figure out what we're trying to find. So I'm going to start by just reading through the problem one more time and writing down the things that I know. So the volume of a gas is 27.2 milliliters. So that means volume 1 is going to be 27.2 milliliters at 22.8 degrees Celsius. So temperature 1 is 22.8 degrees Celsius. We'll convert that to Kelvin in just a minute. And the pressure is 0.523 atmospheres. What will the volume be at 17 degrees Celsius and 1.04 atmospheres? So we know we're looking for a V2. What will the volume be? So that tells us that we don't know volume 2. At 17 degrees Celsius, so that's my second temperature, and 1.04 atmospheres is pressure 2. So this is what I know and what I'm looking for. And because I have so many things going on here, I have so many different variables, I'm going to be using the combined gas law. P1 V1 over T1 equals P2 V2 over T2. There it is. So I'm going to take what I know and I'm going to plug it into my equation. Now remember, I'm solving for volume 2. So I want to make sure that I can isolate volume 2 on one side of the calculation in order to solve for volume 2 when I'm doing this problem. So first, I'm going to take what I know and plug it in. Pressure 1, 0.523 atmospheres times volume 1, which is 27.2 milliliters. Divided by temperature 1, 22.8 degrees Celsius. Let's convert that to Kelvin. 22.8 plus 273 is 295.8 Kelvin. And that's equal to my second set of conditions. Pressure 2, 1.04 atmospheres times V2, which is what I'm looking for, divided by temperature 2, which is 17 degrees Celsius, and in Kelvin, that is 290. Okay, so here's my work. I'm solving for V2 right here. So I want to isolate V2. That means that I want to bring this 290 up to the numerator of the other side, and I want to bring this 1.04 atmospheres down to the denominator, and that'll allow me to separate volume 2 and isolate it in my calculation. Okay, so just so everybody can see, I'm bringing the 290 up and I'm bringing the 1.04 down, and I'm going to solve. So what that means is that I'm going to start with my numerator, 0.523 times 27.2 times 290. I brought the 290 over from the product side. And I'm going to divide that by 295.8, and I'm going to divide again by 1.04. And that'll allow me to isolate volume 2, which will equal, let's take a look at my sig figs here. We want 2 sig figs, 13. And because the unit on my given volume initially was milliliters, the unit on the answer will be milliliters. Units aren't as important yet, except for the temperature units. Those must be in Kelvin. But as far as pressure and volume, it doesn't really matter what the units are as long as they match. But you will see when we get to the next lesson on ideal gas law, units are going to matter a little bit more, and we'll talk a little bit more about converting those units. So I will see you guys in a few minutes.